Okay, now as you can see, how do we handle transformations where we have more than one transformation? So this is called successive transformation. Now here you are going to transform an object to one point. Then after that, you also transform it from that point to another point. So you are going to transform it more than once. So that one is what we call a successive transformation. So an object can be transformed more than once, i.e. it can be rotated, deflected, translated at the same time. So you can do it more than one. So like here, you transform from A, B, C to A prime, B prime, C prime. Then from this to A double prime, B double prime, C double prime. This we get as double prime, double prime, double prime. Assuming this matrix here was F, the first matrix, and this matrix was F, the last matrix. A single matrix that can transform A, B, C directly to A double prime, B double prime, C double prime is given by, we get the last matrix you used times the first matrix you used. That's why I say the last times the first. L is for last, then F is for the last. For the first, a single matrix down, so that's how, if you want from here to here. Now sometimes you want from this to this directly. So there, a single matrix that can transform A, B, A double prime, B double prime, C double prime, back to the original object. ABC is the inverse of L times F. So you get the last matrix and the first matrix, then you invert it. That will be the matrix that will take it back to the original object. So we have an example here. Even the triangle ABC with the vertices was transformed by to A prime, B prime, C prime. Then A prime, B prime, C prime was mapped to A double prime, B double prime, C double prime using an arithmetical factor 2. Find the coordinates of this and this. A single matrix that transforms ABC direct to A prime, double prime, B double prime, C double prime. Now, we have seen that we have a scale factor, but it's the last matrix. We have first of all this. Now, we know that orange, our matrix of transformation times the object, we shall get our image. Now from here, we have our first matrix as M. Let me call it our first matrix. Here it's going to be 1, negative 1, 2, 0. So this is our first matrix. When I put it here now, I'm going to be having now 1. Then my objects, I have A, B, and C. We now convert them to column form. 3, 1, then 2, 3. Then when we do this, we are going to get now the image, which is A prime, B prime, and C prime. So that's one right here. We have all entries are non-zeros, so we go hand way. This times this is 1 plus this times this. So we get 1 plus this times this, negative 1. Then this times this, we get 3. Then plus this times this, negative 1. Then this times this, we get a 2. Then plus this times this, negative 3. Allow me to increase on my size of this matrix here. So this is going to be plus negative 3. Then I cross it there. When I come now to this, sorry, this one is a bit. Okay. When I come now to the last of this now, it's going to multiply this one. So this times this, we get 2 plus a 0. So this times this, we get a 6 plus a 0. But I told you, if you have a 0, just get this, you multiply it in the upper things. This time is 2, we have 4 plus a 0. And instead this one is going to be now 0, 2, 3 plus negative, that is 2, 6, then negative 1, then 4. So now our A prime, we need the coordinates, is 0, 2, then B prime is 2, 6, and then C prime is negative 1, So these are the coordinates for A prime, B prime, C prime. Then now these ones we are mapped to A double prime, B double prime using enlargement scale factor 2. Now if we are talking about enlargement scale factor, we know that always our K is 2. I will set our matrix or with scale factor, this 2 about the origin. Okay, this one is moving and this one is about the origin. About origin is always given by K 0, 0, K. So it will be now our K is 2, so 2, 0, 0, 2. So this is our matrix of enlargement about origin. Okay, so now I know that now still my M times object is going to be according to the image. Now my matrix is 2, 0, 0, 2. Then I'm multiplying it now with the image, the object is going to be, now this is going to be the object to this one. So this is our object. A prime, B prime, C prime. So this is going to be now our object, this image. So that's why I'm getting these coordinates for A prime, 0, 2, then 2, 6, then negative 1, 4. When I cross there, I'm going to multiply them. I get A double prime, B double prime, then C double prime. Let us see. Now we start this row, so multiplying is 3. But good enough we have a 0. Whenever you have a 0, it's okay for you to smile. So 2 times this is 0, this time this is 6, reading as 0. 2 times this will get 4. 0 times this is 0. 2 times this will get negative 2 and a 0. So instead, whenever I have a 0, you just check which row is it multiplying. So this 0 is multiplying all these elements to 0. Now when you come to the second, this one is multiplying all the entries in the first row to 0. So just get this time with this ones here. Because this time this will be 0, this time this will be 0, and this time this will be 0. What you do, just get these two, you multiply it throughout the last row. So this time this you get 4, this time this you get a 12, this time this you get 8. Now our coordinates A double prime is 0, 4. B double prime is 4, 12. Then C double prime is negative 2, 8. And that is, those are the coordinates. Now, we come to Roman numeral 2, a single matrix. Then Roman numeral 1, a single matrix that transforms ABC direct to A prime, B double prime, C double prime. You say, if you want that, you get the last matrix times the first matrix. So, that matrix is going to be our last matrix times the first matrix. So now, our M here is going to be our last matrix. The matrix we used last. This is the matrix we used last. So, it's 2, 0, 0, 2. Then times the first matrix. The first matrix we used was 1, negative 1, 2, 0. So from after that, now we can easily get our matrix. You see that we have 0, so this 0 is going to multiply, this one is 0. So just get this 2 times this. 2 times this you get 2, 2 times this you get negative 2. Then this 0 is multiplying the first matrix, the first row. It's going to multiply all these ones to 0, so just get this times this. 2 times this you get 4, 2 times this you get 0. And that will be the matrix. So this is the matrix, and now transforms it. Now AB direct to this with ease. So that's it, members. Now we are going to see more examples about this. I wish you well.